Good morning, everybody. Yes, same person. It's spring, so the beard is gone, and my face is cold this morning. Great example here of how trees grow differently when they're out in the human-built landscape in the open relative to the forest, which is where they really want to be, right? This red oak tree is indigenous to the northeastern forest, not the northeastern front lawn. Now that's a new thing, okay? Prairie, different situation. Not many trees grow out there in general. They tend to grow together when they do. Trees are never going to choose to be isolated and never especially going to choose to compete with grass like this. But my point for today is about the way this tree grows in the presence of 360-degree exposure to light. There's no competition here. There's no one around to guide this tree to be straight and tall. So look what happens here. At the base of this tree, we have a trunk flare diameter at grade of just about 22 inches. 6 feet off the ground, we're down to about 10 or 12 inches. 12 feet off the ground, we're down to 7 or 8 inches. 20 feet off the ground, 3 or 4 inches. So if that's a highway, what's happened is the traffic here is going off into all of these side streets. If this is a house and we're building a foundation, we don't have the stability, in this case, a solid, large trunk supported by smaller, subordinate lateral branches. That's what we want, and that's what we have to recreate. So that's pruning, that's structural pruning 101. And we as arborists didn't even really understand this until relatively recently. Trees have been doing this for millions of years. And we finally started to pay attention and understand that in the interest of long-term sustainability and structure that will tolerate especially the extremes of climate change, we have got to prune to promote a dominant central leader in trees that are naturally prone to that form. And that's the vast majority of deciduous shade trees and coniferous forest trees. Now, smaller understory trees and what we call ornamentals, things like the yellowwood, magnolia, crab apples, dogwoods, those are small trees. They can branch out lower because the ratios are just not the same. That tree's never going to be 80 to 100 feet tall. So those levers, those branches here, are never going to be that big on a dogwood. If something breaks off in a heavy wet snow, it's not that big of a deal. Plus, those are understory trees, so they're protected by the canopy of trees like this red oak. So here we are out in the open in someone's backyard, and we have to recreate this dominant central leader so as to set this tree up for success going forward. Not only does it not have any companions to share the forces of the wind, to distribute the load of heavy wet snow and ice, but it has the competition of the grass and too much light, too much growth in the wrong place. So we're going to guide it by doing crown reduction, reducing these lateral branches back to a point where we are redirecting the growth into smaller laterals off of the lateral and building a crown that is made up of a dominant central leader, thicker leader, and a bunch of lateral supporting characters. If the rain or ice or snow come along and snap one of those off, we're okay. That's how trees are built, to be able to tolerate damage. Smaller branches bend, bigger branches break. We're going to make smaller branches relative to that central leader. This is a young tree, and 50 years from now, it's going to look very different if we have our way. So hopefully the owner is hip to having us come back every 3 or 4 years and do some more tweaking. This will be the first time since this tree was planted that it will have been pruned and receive some structural pruning love today. Okay, take a look, and I'll see you in about 5 years.